guys, it's just a continuation of the constant rule and the power rule. Okay, I'm sorry, as I've made these videos, I've totally put my husband to sleep and he's snoring in the background. So if you hear that, I apologize. Okay, here we go. So in the last video, I just taught you about the power rule and the constant rule. So just to summarize, the constant rule said that the derivative of any constant, like the derivative of y equals 6, the derivative of that is going to be 0. So we proved that in the last video. And we also proved the power rule, which was the derivative of something to the power of something. So like x to the power of 2. If we took the derivative of that, it would be 2x to the power of 1. Okay, these are just like super small rules that kind of combine the constant and power rule. I'm not going to prove them, so I'm just going to tell you what they are, and this will be the shortest video ever. So the constant multiple rule is just saying if you have a constant multiplied by a function, then that's just going to be the derivative. Then the constant is just going to be multiplied by the derivative of that function. So for example, if we took the derivative of f of x equals c times g of x, the derivative of that would just be c times the derivative of g of x. So just to show you an actual example with numbers, if you had f of x equals, let's say 2 times x squared, then the derivative of that is going to be, the 2 will remain. I guess I shouldn't, you know what, it's a lot of 2's. Let's make that a 3 just so we can distinguish. So the 2 stays. Then we just bring the 3 down, x, and then we subtract 1 from the exponent, so it would be to the power of 2. And then we can simplify that further because we can multiply those to be 6x squared. So that's a constant multiple rule. So it's just like using your power rule and you have a constant in front of it. So that's how that works. Okay, your sum rule is just when you have two different functions and you're adding them. Turns out, it's awesome, you can just take the derivative of each one. No big deal. So just an example using numbers. Sorry. If you had a function like x to the power of 4 plus 3x squared, I'm just adding my constant multiple rule in there too. If I wanted to take the derivative, I would just take the derivative of each term. So the derivative of x to the 4 is 4x to the power of 3, using my power rule. Oops, sorry. Plus, then I'm using my power rule and my constant multiple rule. So, oh my gosh, I'm just going to take a shortcut and I'm going to multiply the 2 by the 3 right away. So make it 6x, and then the exponent becomes a 1. So that's the sum rule. And then the difference rule is exactly the same as the sum, except you're subtracting. So the derivative, oh God, is the loudest snore, would be, you just take the derivative of each function. So I'll just show you an example. I'm going to switch it up to a y just for fun. So we have y equals negative 2x to the power of 3 minus, let's say 4x. So if I want to take the derivative, dy by dx, turns out I can just take the derivative of each one at a time. So the first one, so I'm going to bring that exponent 3 down out front. That's going to turn into a negative 6x, and then my exponent's going to become a 2. So I did that one. And then if I take the derivative of this one, it's just going to be negative 4. Because that's just a 1. So 1 times negative 4 would be negative 4. Sorry. And then if I subtract my exponent up top, so if this would actually be like 1 minus 1, which would be 0. And I know that x to the power of 0 would just be 1. So I'm not going to even write it. So there you go. There's 3 more rules, which are kind of not too bad.